Afternoon, everyone. I'm Paul Angus from ShapeBlue. I'm going to be talking about backup and recovery, which has long been I think a pain point for people using CloudStack or using cloud in general, probably. I'll just quickly go through the marketing blurb because you've probably heard it a million times by now. And this number here is depressingly keeps going up by quite a lot. So keep going for that. Right, so the kind of agenda of what I'm going to talk about. First of all, I'm going to, if you like, digress slightly and talk about snapshots and what they are. And then why we've put this word framework in our backup and recovery kind of title. And then explain what this framework does, what it works with, and then give a bit of an example. And hopefully those titles will start to make more sense as we go through. Hopefully I'll start to make more sense too. So starting off with what is a snapshot.
We know what they are not.
No, they're not backups. So,
You're ruining it.
okay, well, thank you. Good night. Starting off, we have the virtual machine snapshot, which is what most people think of when you talk about snapshot. It's the hypervisor capturing a kind of point-in-time image of your virtual machine. Various mechanisms behind that. Some of them kind of don't do what you think they do, but either way, that's what you're going to end up with, is a point-in-time image of the entire virtual machine. Then we have the volume snapshot in CloudStack, and that is slightly different. That is taking a point-in-time image of a volume out of a virtual machine, and then copying that to secondary storage. And the actual mechanism is using the VM snapshot first, so that it is point in time, then copying that whole lot out, and then getting rid of the snapshot again. And the reason we talk about, well, I've started off in this talking about snapshots, is because, well, the features you get from these volume snapshots are that you've now got a copy of the volume somewhere else other than on the original primary storage. You can schedule when these snapshots take place. You've got a retention policy you can set. Say I only want to keep the last 5 copies of that from my schedule. You can create new virtual machines from that snapshot image, assuming the snapshot of the volume was the root disk. And that's kind of like restoring a VM to how it was. No, it's not quite, because we create a template of the virtual machine and then create a new virtual machine from that. So MAC addresses have changed, various things will have changed. As far as CloudStack's concerned, it's actually a new VM that just happens to have an identical disk image. And you can export that volume out of the system. So you can say, right, I've taken a snapshot, I want to copy out and do something else with. So from most ways of looking at it, this is as close to a backup as we've got. And it's pretty close to a backup. But at the end of the day, it isn't, as we all know now, a backup. So why isn't it as good as a backup? Well, does anyone else think that looks like Tim Mackey? Because every time I see that, I think that's Tim Mackey. It's not going to be consistent across your volumes. So if you take a snapshot of each volume, so you've got 3 volumes on a virtual machine, you're going to have one bit early, then the next bit, and the next bit. And if you've split that into your operating system, say a log directory and your data directory, they're going to be all over the place. And if you try bringing those back together, it's not going to match up. Logs are going to think stuff's been committed that hasn't happened, or logs won't contain things that have happened. And it's just going to give you a big old mess when you try and put it back together again. And you can end up with what you might think looks okay, but then you look a bit closer and go, oh, no, that doesn't match. Now, if you just take a volume, well, that's going to be consistent because it was a VM snapshot of that volume. But for most people, their VM will be running when they do this, because few people will be shutting a virtual machine down, taking a snapshot, starting it up again, which means the kind of more they're not going to be application aware. So if you've got a MySQL database or an Exchange server or whatever else sitting there churning away, even if they're all on the same disk, it's not going to be flushing logs. It's not going to be writing things to disk first that were in some cache or other in memory. It's not going to be making sure everything's good. It will be like you pulled the plug out and you're going to hope that your database is fine or whatever when you plug it back in again. So I wouldn't trust a snapshot with important data ever. If I'm taking a snapshot of a virtual machine I'm working with, I shut it down first, take the snapshot and start it. And then I know everything's been flushed, everything's as it should be. You do have, with a couple of hypervisors, VMware tools and Zen tools, which are at least partially aware of the operating system. And they're going to have a bit of a go at trying to fix things that they're aware of. But any kind of separate database, anything that's doing transactions, anything that's got stuff in memory, you're going to have lost something in there. Anything in memory is lost, so you've lost something somewhere. And then someone was talking to us earlier saying, oh, doing the backups, or snapshots, it's so slow. Yeah. You've got to transfer all this data from primary storage to secondary storage. And in the case of vSphere, we have to compress the thing into an OVA because that's how vSphere moves stuff around, which means we've got to stream to the secondary storage VM the full thing, which is going to compress it and try and stream it on to the secondary storage itself, which is a big processor load as well as 2 lots of moving data. And then finally, CloudStack locks out a lot of other actions while it's doing those snapshots to stop people shutting down a VM while it's in the middle of a snapshot or doing all sorts of things, moving it while it's trying to snapshot it. There are some workarounds that some of the hypervisors have put in place, like asynchronous snapshots, where you tell the user, yeah, it's done, and move the data in the background. But if I was taking a snapshot because I wanted to make a template, I'm going to be sitting there saying, right, I want my template now, and CloudStack's going to be saying, but I haven't actually finished. To which the user says, but you told me you had. And CloudStack will go, yeah, but I haven't really. So it's kind of, that's not going to keep everyone completely happy. And then there comes to restoration of a virtual machine. And I kind of said if you take a snapshot, you can kind of restore it, but not really. When you think of the process that you've got to go through, you make a template from the snapshot you've got, then you deploy a VM from that template. Now that means the virtual machine image has got to go from being a snapshot to a template, which means it goes to the secondary storage VM because it's copying that, probably back to the same storage in a different location as a template. Then you're going to copy that template from that secondary storage down to primary storage, assuming your primary storage is network-based. You're then doing another kind of loop. And then finally, you've got it as a template, and you need to deploy it as a VM. So you've got either 4 lots of network copies and 1 on-disk copy to do this one thing, which, if it's a large image in the first place, is going to be moving an awful lot of data around. If you're to go to the back end and say, well, I kind of know where that image is, so if I just take that image and copy it over the original one, I can put it back and it's exactly as it was and no one really noticed. There are operators who do that, and people have to write an email to the operator who then emails around various different departments, because the storage guys need to get it, then the hypervisors guys need to put it in, and then the CloudStack guys need to maybe fiddle with the database a bit to make it look like it's still there. It's possible, but it takes a whole lot of back-end operator work to get that to be back where it came from. So, the backup and recovery framework at last. Why is it a framework? Well, we call it the framework because in itself, it's not supposed to do physically anything. It's a vehicle to make life easier for everything else. We have the idea of plugins, which provide the link from the framework API to whatever the backup and recovery provider is behind that. And there is a dummy frame plugin as well, so obviously it needs to run through testing, and so to be able to drive those APIs and make sure you get valid responses back, we've got that. And so that's the end of my short rubbish presentation. What does this framework actually do then? So, to give in kind of marketing-y speak, it's creating a vendor-agnostic API and UI for CloudStack for the end users to leverage the third-party backup and recovery solutions. So basically, we're abstracting away all the things the back-end backup and recovery solution will do, giving a fixed set of hopefully obviously named APIs at the front, so then users can say, I want to back that virtual machine up. And how that happens at the back doesn't matter. They've got an API that does that. I want a list of all the backups I've got. You send us that. Between the plugin and the back end, we'll then return you that list. And so basically we're abstracting away those two layers to make it simple for people. So for the good old cloud operator, the person running the cloud, they've now got a lot more control over this back end process. They can decide how it gets done. To an extent, they can decide when it gets done. I'll talk about that in a second. Obviously, a lot of backup solutions are trying to find ways to make things faster, be it in compression, in the way they do chained backups. I'm trying to think of the word there. Whether the things talking to the hypervisor and directly moving that on storage, or even talking to the storage directly and just making a copy internally. All sorts of things that these backup systems can do. Reducing the operator overhead, it's moving much towards being able to offer backup as a service, to be able to allow people to just do their backups and recover their backups and not have to get involved as the operator. It's also good to be able to offer more features and things that your backup providers can do, particularly speed. And then obviously the advantage of being able to charge for this sort of backup as a service and have it as a stream in itself. But for consumer, one of their main things, and actually that can go in the section for the operator, is the much better performance because of the enhancements and the shortcuts that the backup and recovery systems can take then over what CloudStack can do, which has to do through the front. It can be much faster, much slicker, and much more efficient. The consumer's getting proper backup and recovery style features that they'd expect to see. And say proper restoration options rather than saying, well, I've got to create a template from my snapshot, then create a VM from my template and kind of pretend it's the same one again. But also what we're looking to do is give that consistent API and user experience. So our CloudStack documentation will be the same regardless of whatever backup vendor is sitting behind it. The things you'll do will be the same. And for those that want it, you can also give them the peace of mind that, oh yes, it's a XYZ backup, not, well, we're just moving a copy of your disk somewhere. You're using a whoever it is brand backup, which some people find important. So more specifically within the framework itself, we support the idea of policy-based backups, where you've, and this gives a lot of flexibility and stops a lot of bottlenecks, because one of the more cloudy ideas in backup for cloud is to just give a restore point objective. So you'll always be able to get back up to 6 hours of data, or you'll never lose more than 6 hours of data. That means the operator can set your individual backup to happen whenever it likes, as long as it happens every 6 hours. So you can start staggering backups throughout the day and night, and you're not tied to everyone's backup happening at 11:30 or 1 o'clock in the morning, or this really small window. That's not what someone signed up for. They've signed up for a policy that says, I'll never lose more than 6 hours, 8 hours, 24 hours a week, or whatever it is. And that gives a lot more flexibility in how you time those actual physical backups. But we'll also have the usual scheduled backups for people to do, and obviously ad hoc backups, just pressing a button. But we will keep those, I suspect, all in the same chain. So you've got one virtual machine. You'll have one chain of backups, all incremental, so you can restore to any single point within that, regardless of how that backup came about. We'll have backups, we have backups as a first-class citizen. So deleting a virtual machine will not mean you've deleted the backup. People will need to explicitly delete all the backups from the virtual machine. So you've got those then, available when you say, oh, actually, turns out we did want that. Or someone can keep their backup for as long as keep one backup of a VM, destroy it, and have that sitting away somewhere. I think some backup vendors have a kind of third or second tier where it might be S3 storage. So something that's been backed up for so long will get moved to S3 so that it's not taking up sort of more faster storage in front of that. So people would be able to leverage that kind of thing. So enabling us to restore backups even after the original's been destroyed. We've got in-place restoration, so you take the entire virtual machine, whether it's got just a root disk or 5 disks, or I'm trying to think what the limit is, a lot of disks, and put that all back as it was at a certain point. But we can also take an individual volume, and if you think, well, actually I've rebuilt my virtual machine, all I need is the data back out of it. The easiest way to do that is often restore the old root disk as just a data volume and then copy it out. That's going to be the fastest way to get data out of one old VM into a new one, just mount it. And obviously, importantly, for a lot of people, will be integration into the usage service. So we'll be adding to what Doug's already got to record what we call protected and on-disk data metrics. So your protected is if I'm got backing up 500 gig disks, 5 times 100 gig disks, then I'm protecting 5 terabytes. If each one of those actually is only 10% used, then I'm actually protecting back to 500 gig. So depending on the model that a provider is using for their backups, whether it's the physical amount of space it's taking up or the protected capacity, either way, you're kind of covered. So in terms of what our framework's going to work with or works with, at the moment we've got the dummy plugin, but we've also got Veeam, the backup and replication. So it's been tested and worked against version 9.5, specifically against the VMware hypervisor, vSphere 6.5. Now, Veeam do for Hyper-V as well. And in terms of taking a backup, it would be no different from the way CloudStack sees it. But we haven't done the bit where you'd restore, because CloudStack's got to know where things have gone. So restoring would be extra work, which we haven't done for that. But doing the actual backup should work out of the box for Hyper-V. You do have to have certain level of that Veeam backup and replication software. You've got to have the console, the enterprise manager, and you have to pay for it, but the OpenSSH and PowerShell on the Veeam server so that we can get to it and talk to it, because Veeam still uses PowerShell to do a lot of its operations. It's got a bit of an API, but it's not a full one. And we've been writing it against what is currently the master, which would be 4.12 at the moment. So our examples, so say still subject to change because we're still in development, and as we move through stages we kind of go, well, that seemed like a good idea at the time, but now that's conflicting with that name and let's change it. But we've got creating and deleting policies and backups themselves, restore points. I think I put a star next to restore points because that's quite a Veeam specific thing. But basically all the basics of creating backups, getting VMs to be part of a backup and in a policy, is all there. And to give a kind of graphical view of it, we start off, I need to explain how Veeam works to an extent, which is that it has the idea of backup jobs. And what we have is you create your template jobs, if you're doing policies, or even if you just you need to specify where stuff's going. So you create your template jobs. We then can list those in CloudStack and say, this job that I happen to have called Zone 1 Silver is what I'm going to tell my users is the silver policy, and my description will be this happens every, 24 hours. So every 24 hours, a backup will happen of your VM. Don't worry about it. When you restore, there'll never be never be more than 24 hours since the last one. So then we import that in and map it so that when you say, I want to use the silver policy in CloudStack, that uses the silver policy you've created it in Veeam. Then obviously we add the virtual machine to that policy. Because of the way Veeam works, we actually just clone the original policy, where's my silver one, and give it a name relating to the VM itself that we're doing. And that's got a job now that is going to run every 24 hours, because that's what the silver policy was, but with that virtual machine in it. And that's just going to keep rolling and rolling. We can also then have CloudStack send an ad hoc command to our VM here and say, let's just do a backup now. And to which the Veeam server will hopefully say, OK, and just do another backup. And that all keeps it all in the same chain of backups. So when you do, as it's another incremental off that, it should be pretty quick. And then you can roll back and see the whole chain. Scheduled jobs will actually be run pretty much the same way, because CloudStack will just, on a schedule, say, do an ad hoc backup. So it's quite simple. And we already obviously have the most of that in place for doing snapshots on a schedule anyway, so it's just an extension of that. And this kind of one VM to one Veeam job, that's kind of how Veeam works, and that's how we can do a lot of accounting, because we then just look at that job and we can say how many VM, how much space is this job using, how long has it run, what's the chain, how many restore points have I got in there, and this unified incremental backups, regardless of which way you got the backup to happen, it's one list. So obviously we have our APIs for listing them. And so in Veeam, you've got a backup is what they would call a job, and a restore point are what we might think of as the backups, are the times it's ran. Now, our API at the moment kind of talks about restore points, but we'll be looking at other providers as well and see what they call them. If everyone calls them restore points, then we'll stick with it. If they actually start calling them different things, we'll try and find what's the most common way of referring to the job and the actual backup, so that we can then keep it clear and consistent for everyone. Also, when it comes to restoration, the Veeam kind of an in-place restoration doesn't just write over the top of the original virtual machine. For good reason. So, because once you've started doing that, there's kind of no going back. You've just destroyed what was there before. And if you then find that it's corrupt halfway through, you've kind of trashed both of them. So what it does is restore a copy of it somewhere else, then delete the original, which is great, but confuses the hell out of CloudStack, because suddenly this VM is now over there for no apparent reason, and probably with a slightly different name. So we've had to write around that actually we ask Veeam, where did you actually put that, then update the database to say the VM is now there. We also have the able to, through one API command at the moment, restore to a volume and attach it to a VM. As one command, you say what you're restoring and where you want to attach it. But but we will then add to that being able to restore it to just secondary storage. So then you've got it, and you can attach it to whatever you want, whenever you want. And then we've got, I think I did that one. I think it says the same as I said before. So that's kind of, it's actually, if you like, quite a simple thing, but it just takes quite a bit of work to do it, and also it's changing the whole paradigm of how people are backing stuff up and looking at it and taking it away. We've looked at obviously changing snapshots, but that would confuse everyone. So this is a whole parallel thing. So work is ongoing. The vast majority is done. So we've got, expect to see a PR are we in quarter 4 yet? Are we in quarter 3? Yeah. Expect to see a PR in quarter 4 for all the back-end stuff with the APIs and all that actual work. And so there's scheduling and ad hoc backups already started. There's already kind of placeholder APIs in place that mostly work. There's a few other bits and pieces, the deletion of actual backups and restore points to do. And then that part is pretty much all done. And then it's just doing the UI. So expect to see, I guess, PR for that coming towards the end of the year when we start fleshing out what that's going to look like. And obviously that will could turn into the world's biggest bike shedding exercise when everyone decides what button should go where. But yeah, it's well underway. The API is largely formed now. And we'll start getting that out for people to have a look at bits of it, hopefully quite soon. How do we do for time? Cool. Any questions?
Currently, there are some combinations of hypervisors on storage, like KVM and NFS, for example, where you can back up and restore to secondary storage, disk snapshots. You can actually, you have a button for restore there. It's essentially back up and restore. What will happen to that functionality going forward? Because this will get implemented at some point.
Well, we're not taking anything out.
So that will stay there.
Yeah. So if people are using it, they carry on using it.
It will become a bit confusing at some point, I guess, if you have that.
If people
and the other thing.
Well, no, because we'll be in a separate wheel. The backup and recovery will be its own thing, and it's based on the idea of using some enterprise, some backup recovery solution that has APIs that can do all that kind of thing. And if someone says, but in KVM it works well enough, then people won't use it. There's only one, I haven't spoken to them yet, I think it's Vinchin or someone, backup, who seem to do KVM and Zen Server and VMware and Hyper-V. They're the only one I've heard of that span all the hypervisors. Backup, generally you'll see in Hyper-V and VMware, not really much in Zen Server, though I think Zen Orchestrator does. With KVM almost non-existent. So if it's about those extra things that they provide. Because can you do incrementals on KVM?
No, it's not incremental. It takes full snapshot, puts it in secondary storage.
Whereas in theory, if you've got a backup and recovery provider, you would expect them to be doing incrementals.
There will be obvious benefits.
Yeah. So, but yeah, it won't be sitting next to the snapshot button that says recover. It'll be in a whole backup section, but it is based on the idea that there must have been a good reason to using an actual provider.
Because it's actually a sort of VM operation, isn't it? You're backing up a VM or a volume.
It's largely a storage operation. Because the likes of, I think, Veeam have agents you can install on the virtual machines, which get told via various mechanisms, I'm about to do a backup by Veeam to try and quiesce and sort out databases and then do that backup. And in theory, there's no reason, if you've got a software-based backup where, what was the kind of old guys like? Backup exec, they become something else, didn't they?
Veritas.
Yeah. They would have an agent in the VM doing a backup, but there's no reason why you can't just say to that agent, stream everything out to this location at this time. And still, you now have a mechanism for doing that. So that's the idea, is it's now just, it is a framework. So there is now a button and an API call to say do a backup, and whoever writes whatever plugin, the plugin could tell someone, email them a USB stick. Yeah. Do a backup. Oh look, my USB stick arrived. Okay. Yeah, world's your oyster.
Yeah, I'm happy that.
Yeah, we're not taking anything else away, yeah, okay. And so it'll be seen as a separate thing. Oh, yeah.
Has there been anyone else other than being interested in this?
Yes.
Yes.
We can't say anymore. Yes. Yeah, and hopefully once it starts getting some traction and whether, then.
Has anyone raised the idea of doing kind of consistency across multiple virtual machines? Like point in time for these 10 virtual machines at the same time?
That would be very interesting.
Has anyone raised this idea? Like maybe it's technically possible?
No. But I mean, again, we're providing an API, so if it then comes, well, I need to extend this API to have an extra flag to do all of these at the same time, then. Yeah, not heard that. Did it see?
Is there a plan to implement the storage backend capabilities to make a snapshot? For example, if you have as primary storage Ceph, and Ceph has a snapshot feature, so if you have this framework, we have to plug in to trigger Ceph, and there will never be this included in CloudStack to use the capabilities of the storage backend.
So
natively, without a plugin.
No,
so
well, I can't say no one else is going to do that, but the plan for this is it's a backup recovery framework, so we're not thinking in terms of snapshots. Now, if someone wants to, because that Ceph snapshot has got to go somewhere, in theory, for most people's understanding of a backup, you can't just be a snapshot on the same storage because it's not gone anywhere, and if that storage dies, it's gone. And the first people say is, where's the backup? And you go, yeah, it was on there too. So, yeah, so this is for backup. Yeah.
You have the possibility to make a snapshot.
Yeah. So we're just worrying about the backup piece. Now, if someone writes a plugin that will call the back end of Ceph to do that and copy it to another Ceph cluster somewhere else that you can say it's physically separate, so then...
For us, we don't want this copy feature.
Yeah.
To copy this to another, because that's no backup. We have another backup solution, but if someone really wants to use the snapshot, you can use it. And we have Ceph as the storage backend, so we don't need to copy this.
Yeah.
So the snapshot is not consistent.
It's I know it's something that can be done. Sorry, still Paul guys, but SolidFire, I know that with their plugin, that changes how snapshots happen. So if you press snapshot for different hypervisors, it will do a different thing, but it will do it. It can do it on the back end of SolidFire nodes and make a copy, and then just tell CloudStack, I made a copy. It's called this. It's just there. And in fact, the way theirs works, which is probably similar because they're both kind of Ceph-based in their lineage. That will happen in the background, and all it is a load of pointers, nothing actually moved. So and CloudStack just needs to know the name of a file, and it'll go, okay then. So it's perfectly possible, and I've seen it done for other platforms, but yeah, that's not, it's different. As we say, snapshots and backups, we're concentrating on what people think of as a backup and want from their backups.
The point in time thingy, is that a VM concept, or you came up with it? Because I don't know VM at all. I mean, the fact that when do you want the restore point? You said you can lose up to 6 hours.
Oh right, a restore point objective is a, God, that's been a term. Yeah, it's been around for ever that I can think of. When you're doing backups, what do you have? You have recovery point objectives or store point, how time and
how much data.
What I meant is that with this plugin, for example, from what I understood, you can't just go and say, I want to backup of this VM at 11:15.
Okay, so
You'll just say, oh no, but we can guarantee you can only lose this many hours.
it's a different way of looking at it. I don't know who first did it. I know Rubric. That's one of their kind of things they talk about. Why theirs is different to traditional backups. You don't show it.
This is happening because you can then spread the
so
load of all this across more time.
Yeah.
But I was wondering, is this a VM thing? Is this what they do normally in their solution?
No.
Okay, so this was your idea.
Well, it's something we've had to. The idea of policies just comes from that more cloudy way of looking at it. And then a customer we were working with, particularly wanted to work with Veeam, so it was an easy way to get a company on board with it. But we've been talking to a couple of others as well, and some are more likely than others. But I think once people see it, and particularly do proper demonstrations with it all working and a UI, then I suspect obviously customers or people in the community will go, I want that. By the way, backup vendor, get yourselves a plugin.
So scheduling, CloudStack does the scheduling of backups.
Yeah.
It decides when to start the backup.
Yeah. So yeah, if they're scheduled or ad hoc, CloudStack's driving it. If it's a policy-based, it's just telling the back end, assign this VM to that policy and do stuff. Yeah. Cool. Thanks.